Scientists explain the Earth pretty well. Scientists have covered most every question about things on our planet to a pretty good degree. There are still things in the universe that we've yet to really answer all the questions about, because we have kind of a lack of knowledge or technology to observe these things. Even then, we usually have a lot of good theories and hypotheses about what those things might be and the answers to any questions we might have. A good case in point would be black holes. Though we've yet to actually observe them, we have an overwhelming amount of evidence that shows that they exist and all of their effects on space-time.
Before explaining black holes proper, we'll begin with some history on how we discovered the black hole. In 1687, Newton began his description of gravity, setting up one of our fundamental laws of the universe. 1783 had John Mishal theorizing that there might be an object massive enough to have an escape velocity faster than the speed of light. 10 years later, Pierre Laplace predicted that object, the black hole. The theory of general relativity was formed in 1915, giving plausible relationships to concepts in time, light, and energy, and showing how they all work. In 1935, Chandrasekhar formed a theory on white dwarfs, lending to the idea that superdense structures can be created from a star death. And lastly, in 1970, Hawking defined modern theory of black hole. Many more theories and advances have, of course, been made since then.
Before we get into the rest of black holes, we should discuss how they're formed. They form from the gravitational collapse of a stellar object. When a star begins to die, it's possible that it can be large enough to form a black hole. The important thing is that it'll first go through a supernova explosion. After the supernova, if the remaining mass is above the TOV limit, which is about 3 to 4 solar masses, all of the matter will start to collapse in on itself, forming a super dense object, the black hole. They're not formed quite like other things in space. They're not formed naturally at all. They only form as a result of stellar objects collapsing. This is because our current universe is way too spread out for there to be enough mass in one space to condense into a black hole. It's theorized that immediately following or right before expansion, black holes could have formed naturally in the superdense universe, and this is a plausible explanation for the supermassive black holes at the center of galaxies.
One of the defining features of black holes is the singularity, the center point of a black hole where matter is infinitely dense, gravity is strong, and space-time curves endlessly. Einstein's theory of general relativity describes the consistency of light regardless of relative measures in the singularity. Even that theory does not apply, though we have no way of understanding what goes on this central point, and many believe that they are simply unobservable. To escape the singularity, one would simply have to break free from its gravity, like one would any other terrestrial body. Due to its infinitely strong gravity, a black hole escape velocity is faster than the speed of light.
Though the singularity is the black hole's most well-known and defining feature, they have a lot of other strange attributes. The ergosphere, which is derived from the Greek root meaning work, is an area beyond the singularity. In this region, it's still possible to escape a black hole's pull, but due to the strength of the black hole, the object will gain a lot of energy and momentum. Therefore, one of the theories surrounding the ergosphere is that one could take energy and mass from the black hole via this area. Black holes also emit a certain amount of radiation, usually called Hawking radiation. As an object nears the singularity, it gains massive amounts of energy, some of which becomes this radiation. Theoretically, this tiny amount of radiation comes off of the black hole and it will cause it to shrink. And over billions and billions of years, the black hole could eventually evaporate.